Okay, let's solve this with energy. Here's the trick. I'm going to say, even if they don't tell you a height, just say, okay, it's going to fall some distance h, right? Okay, because then, if it's going to accelerate, it's got to move, right? Okay, so it's going to fall some distance h. Now, the trick I'm going to use is this. Okay, if it falls that distance from rest, even if it doesn't, by the way, you can still use this trick, okay? V squared is u squared plus 2 as. If it falls a distance of h, and if the initial velocity is 0, then v squared is just 2ah. So therefore, a is just v squared divided by 2h. Now, what I'm going to do is I'm going to make an energy expression. When I arrive at v squared, all I have to do is divide by 2h, and I've got the acceleration. Okay, that's the trick. That's the trick. Set up an energy expression, solve for what v squared is, divide by 2h, and you've got the acceleration. Okay, energy is easy peasy. Okay, so this thing, I don't have to worry about torques and systems of equations and substitutions. I'm just going to set up one equation here. It's simple. Okay, our total potential energy is m2gh. Okay, now right before this strikes the ground, if it does, right, that thing's translating, this guy is rotating, right? So that's going to become 1/2 m2v squared plus 1/2 I omega squared. Okay, so this guy will be translating, this guy will be rotating, right? Okay, standard substitutions. This guy is we're going to substitute for the moment of inertia. It's a thin ring, so that one is all of mr squared, right? So that's m1 r squared, and then of course we substitute v over r for that, right? Okay, so now our next step looks like m2gh is 1/2 m2v squared plus 1/2 m1 r squared times v squared over r squared. Right, obviously the r squareds go the way of the bison, right? Okay, so we end up with m2gh is 1/2 m2v squared plus 1/2 m1v squared. All right, now let's factor out the v squareds, right? Is v squared outside of 1/2 m1 plus 1/2 m2, right? So now v squared is equal to m2gh. Wow, that's a weird m2. m2gh divided by 1/2 m1 plus 1/2 m2. Okay? And now all I have to do is divide this by 2h, and it becomes a. So let's divide this by 2h as well. Well, the h's go the way of the bison, right? And then we multiply that by 2, and we end up with m2g divided by, well, 2 times 1/2 m1 is m1, and 2 times 1/2 m2 is m2. Okay? Now, if you're paying attention, that's the acceleration. That's exactly the expression that we got using dynamics. All I had to do, my physicsing was done here. All I had to do was just substitute and then use this trick. I had to use this trick, right, to find the acceleration. But there we have it right now. Obviously, at the point where I have v, I could have square rooted that and gotten the final velocity. Suva to define this. But my point is that I can arrive at the same expression for an acceleration using energy as I do using dynamics. Okay? Happy hunting.